We're ready to begin our Tech Talk today on mastering frame design and solid edge from basics to advanced techniques. Our presenter today is Pratik, who is located in our Cincinnati office. He is a solid edge application engineer at Prolim. He recently graduated Michigan Technology University with a Master of Science degree with MS Design, FEA, Manufacturing. Pratik, the Tech Talk is now yours.
Good morning, everyone, and welcome to today's Tech Talk on frames. So here I have a pressure booster pump station assembly here, as you can see, with a couple of cylinders, some motors, some pipes, etc. Now, the goal here is to create the base structure using frames. So we'll start with a new assembly here, and in the new assembly, we'll try to bring in we'll try to bring in this pressure booster pump station, and then create the frame in a new assembly. So let's start with that. So here I'm just going to go ahead and create a new isometric assembly. Now in this new assembly, as you're aware, whenever you try to create frames, you will always have to create frames within assemblies. So frames are available inside the tools tab and under frame. So this is what your frame environment is going to look like. Now before I bring in or start creating my frames using sketches, I would just go ahead and create a new component which is going to be the base part. So here I have two different options to create the to create components is by so one is to use the regular create part in place command, and the other one is to create internal components, which means that the internal components will reside inside this assembly number 4. So here we can start to create using the internal components. I'll just give this a name as let's say base part, and here you have options to decide if you want to ground the component itself, and if you want to assign any specific material to this component. Since I'm not too much worried about what materials assigned to this part, I can just go ahead and say none and start creating my component. So as soon as I do that, you'll see that I'm put into my sketching environment where I can start to create my frame. So this frame here will be placed on the XY plane, or the base part here will be placed on the XY plane. And this is going to be a 3500 by uh, 2500 part or sketch here. So let's do that. This one is going to be 3500, and this one right here is 2500. So once I have my base ready, I can extrude this part to a height of 175, and this is how I can create my base. Now so that I can see things more clearly, I can use the model view or the style palette to turn this into a clear model. So what I can do is I can say use any color. Let's use black in the form of a clear color, which will be easier for me to select any edges when I have a lot of components in my assembly. So here I'll just say close the assembly modeling, and now this is my base part. Now I can use this base part as reference to create my frames. So to do that, I'll go back to my tools, and within tools I'll go to frames and start creating frames. So first you come to the frame command, and as soon as you come to the frame command, you'll see this frame options dialog box pop up. So this is where you set the global settings for all the frame members you create for that instance. For example, which is going to be a preferred frame orient XY plane, I can use that as my preferred frame orientation, and then what kind of corner treatment I want for my frames. you can have a mitered corner treatment, and about which plane do you want that to be mitered, xy, yz, or xz. And if you want to create a butt end, about which axis will this butt end be, x, y, or the z axis. So depending upon what kind of corner treatment you want, you can select or change options from here, and this is going to be the global setting for this frame instance. So I'm just going to use the defaults for now, and instead of selecting edges one by one, I can just say select the entire body, which selects all the edges for this specific body. So that's a quick and easy way, or you can say a method of selection for this entire part. Now, from the drop down, I can decide what frame cross section I want. So, looks like these are the frame cross sections I used previously when I created my frames. But if you want a more detailed selection, you can come to the select cross section component, and it puts you into this browse mode from where you can select what standards you want, and from that standards, what cross section do you want: angle, C channel, I beam. For my application, I want a square tubing, and I want a 80 by 80 by 5 square tubing. And once you select that, you can hit the screen check box, and the software generates the frame for you. And if you remember from the options that we had selected, I have my mitered on my XY plane, as you can see here. And then I have my frame preferred axis is going to be the XY axis. So it looks like everything here is working based on my settings that I've set in my global options. Now, if you want to change the end conditions here, you can always go back to options, and then instead of XY, let's say you want mitered about the XZ plane, right? So if you select that, it changes things, and you'll see mitered along the XZ plane. And since this is global, this will be applied to the entire frame instance. One is over here, as you can see, one more over here, and the last one is over here. It, so I'll just go back and use the XY plane for now. Now, if you want a local control, if you don't want to change everything, and if you want a local control over one of the corners, and you want to change the end conditions on that specific corner, you can come to the edit end conditions, and from here you can select what corner are you focused on. So for this instance, I can select these two corners. You can hit the green check box, and now here you'll see I get the same options. If you want mitered, if you want a butt end condition. So here let's take a look at the butt end conditions, and what is going to be a preferred axis. Right now it is using my x-axis as a preferred axis. From this selection, I can change that to the y-axis and then the z-axis, right? So I can make all the changes I want from from the edit end conditions, which will be a local control, because all the other end conditions are still the same that we have set under the global conditions. Now I'll just default back to my original condition, and this is how you can create frames for a specific part file, or a body that you have imported. Now, how about we create some sketches and generate the frames based on those sketches. So here, let me hide my frame component. And now here, I'm going to create a back panel support for my control box. So for that, I'm going to use the sketch. So I'll just sketch on, let's say, this plane over here. And for the dimensions, let's see, I have something like this going on. And I want the midpoint of this line to align with the origin. So I'll select the horizontal vertical command to align that. And now the dimensions here on The vertical side here is 1425 mm. Then on my horizontal side here is 1030. I have the smaller control box here, and the dimensions for this one here is going to be 865, and the back support for the control box is going to be these two cross members. So this is what my sketch looks like, and as you can see, my sketch has turned black, which means it's fully defined. And I can close this to finish my control box settings. So here I can turn back on my frame components, and now we will go ahead and create the frame for this back support. Right now I'm going to create frames, and under this frame here I'm going to use a different cross section. For this example, I'll be using a C channel 50 by 25. For here, now since we don't have a part file per se, I'm not able to select any edges, right? So I'll have to change this to, let's say, single or chain, and then the software generates or selects the entire sketch. For 50 by 25 C channel, this is the sketch I want, and everything looks good so far. So this is how the software generates that C channel section for me based on the sketch I have. Okay. Now for this application, I want the flat side of the C channel to be on the back side of this support. So for that, again, what you can do is you can go to options, or sorry, you can go to edit cross sections, and from here, if you see, it highlights all the cross sections for this frame number 2. So I'll say, okay, that looks good. And from here, I can simply change my orientation from 90 to 0. So what happens is, this is what I want. I want the flat side of the C channel to be faced on the back side, and this is what is the end result. All the members here, I have changed their orientation to 0, which defaults to C channel orientation based upon the cross section member that was created, and this is what I get. Now once I have that, here if you take a closer look in this region, you see how these two members are practically intersecting, which does not simulate the real world conditions. In real world, you would have a certain section cut out in between. So inside solid edge frames, you can simulate the real world conditions by creating that section too. So for that, I'll go back to frame under edit options. Here, if you expand the options, you have this you can turn on the selection that says split intersecting frames. So as soon as you turn that on, you'll see that the software automatically splits the frame. So now this is the software generated default frame split. Now, for example, let's say if you want to split this member instead of this one, you can always revert or invert the selection too. So for that, we'll go back to frame under edit end conditions. We'll select which end conditions I want to edit, which is going to be this region right here. And in this region, I want to select the next collinear option. So this next collinear option in this situation is going to act like a toggle switch to invert the selection. So this is how you can simulate that real world sections inside solid edge frames. Now since I have this part ready here, which kind of simulates the overall condition of how I want my frames, I'm going to bring in this pressure booster pump assembly into this assembly number 4. So I'll go to my parts library, and let me pin this here, and I'm going to drag and drop this assembly. Okay. Now, to better assemble this pressure booster assembly, I will go ahead and try to rotate this real quick. So I'll rotate this by 90 degrees, which gives me a better orientation of how I want my assembly to be. So using my assembly relationships, like let's say planar align, I can align the plane of this control box with the support control box frame. So that's number one. So number two, I want to also align this frame, this face with this face of the frame. And the last one, I want to create a face made between this face right here and this face for the frames right here. So this is what my control box location and orientation look like, which pretty much aligns with how I want my frames to behave, and the location looks good based upon the measurements I had. Now the next part here is going to be where I generate the cross members for this base for the base frame. And once I generate those cross members, I'll also have to generate the support members for these two tanks I have here. So tank number one and tank number two. So let's go ahead and start working on that. Now for that, I don't have to go ahead and recreate a new part itself. I can just use the existing edges to make the sketch. So just for my ease, I'm going to hide my frame members here and create a sketch. So I'll just go to sketch here and use so I'll make a sketch on this plane, let's say. I can use the existing edges, which will give me a point of reference. See, this is kind of confusing, so let me hide my sketches too. So I'll go back to my top plane and align with this line. So this is the line I have, and from the other side I just need to connect it to the edge, so I can use a connect relationship right here to connect those lines. Next, we'll follow the same steps on the other side. We use this edge over here and align this with and now I can use the connect relationship between this point and this edge. That looks good. And one more connect relationship between the endpoint and this edge. And the last one here is going to be the same line we have, connecting line 1. So this is what my cross members look like. And one more thing I also have to do is create support or the frame members for this motor. So this motor has bolted in at 4 different locations. So I need to create 2 frame members for the motor. So first, let's create one for this. That is, I want it to come from the midpoint, connecting the edge. And the other one is going to be the same location, connecting from the midpoint of the bolt. Sorry, let me try that again. It's connecting from this side of the base part to this side, and then I'm going to use the connect relationship. Now, since I don't require each and every section of the sketch, I can trim off the regions that I don't want. So I don't want these regions right here, these two, and these two. So this is what my end sketch would look like. So once I have the sketch, I can start generating the frame members now. So for that, again, I'll go back to my tools tab under frames. I'm going to use this existing sketches here. So let's go to frame. We'll use the defaults. Now for this, these vertical members, I'm going to use 80 by 80 by 5 section. So 1, 2, 3, and 4. So these 4 members here, and the software generates the frames. Now if you see, the frame here has stopped exactly at this point and did not complete unto the until the end of this point. And the reason for this is because the software identifies the existing frame members and only extends the members such that there is no intersection between the two cross members. So the software in that sense is very smart to understand uh, how many existing frames are there, and where exactly are they placed, so that while extending there is no intersection. Same thing we'll do on these horizontal members too. So let's go back to frames, and we'll select the sketches, sketch 1, 2, 3, and 4. And for these 4 sketches I want to use a 50 by 25 C channel. Now, one thing you'll see at this location is that this frame, there is some gap here placed between the flat face of the frame and these bolts right here. Okay. Now, to move this frame location, or to move it from one plane to a different location, what we can do is we have something called as control points that lets us do that. So for that, what I'm going to do is I'm going to come back to frame 4 and edit. From here, I can go to edit cross section step, and this is very similar to what we did for the C channel when we rotated the region or the faces for this for these frames here. So instead of rotating here, we are simply going to use the control points. So first we'll have to activate all the control points and use the control point to which you want the frame member to move. So right now the sketch here is located with respect to this blue control dot. Now instead of that blue, I want the frame to move to this red control dot. So now my sketch moves to the red control dot, and now it intersects with the bolt right there. So that's how you can move all the frame members. If you see, all the 4 frame members have been moved since they were made inside the same frame instance. So we have 2 frame members that have moved up here, and 2 have moved up here. So that looks good. Now the next step is where we define the frame members for the support of these 2 tanks. In order to do that, I'm going to use, let me use, let's say, let me hide all these frame members first and the sketches. So here I'm going to create one more internal component and use the part as reference to create the frames. So from the drop down, I'll say create internal component, and we'll just give this as a name as tank support. And this has to be added to assembly number 4, so that looks good, and accept. So now I'll be creating a solid on this face right here. Now instead of making an actual sketch, I can use project to sketch and use the existing edges to make a sketch. So once I have this, very easily I can extrude that. So I want to extrude it on one side, and since I don't know the exact distance, I can do a from to next. So I can select this face from this face. So the software generates exactly how much up to which face you want to extrude that to. And again, like we did for the base, I'm just going to convert this to clear. So I'll just go back to my uh, style palette and use the same color applying to the model. It just gives me a better understanding of what is around that part. Now once I have this, I can bring back all my frames. And here, let me go ahead and hide my subassembly and select only the frame members or the edges that I'm interested in. Because in this specific instance, if I use a body, it is also going to create a frame member which will be intersecting with the existing frame members, which is not what I want. So here, it would be a good idea to use single edges. So I'll go back to frame and go to frames, use the default settings here, and now I'm going to select the edges which I'm interested in. So these four and these four right here. Let's see. So that's my first support, and this one is going to be my second frame support. Right now, for this specific frame, I'm more interested to use a different frame cross section. So let's go to square tubing, and this time we'll be using a 50 by 50. Since we don't need 80 by 80, that's too big for the tank support, we'll be using a 50 by 50 cross section, and let the software generate those frame members. And again, you'll see that the frame member exactly stops where it is supposed to. It is not intersecting with the existing frame members because it knows where the current frame members are and where to stop. Now the next step is I bring back my pressure booster pump station, and this is what my current assembly looks like. So everything here looks good. We have supports for the motor. We have support for these two tanks, which was a part of subassembly itself. Again, we have support for this motor. We have support for these two tanks, as you saw, and we have a support frame for the control box. Looks like I might have hidden these some faces. Let's bring them back right here. Okay, so I have support for my control box. So this is what my entire frame is going to look like. Okay, so this is all I had to show you about the existing frame and how to create frames. Now we will take a look at some of the enhancements that have been made to the frame environment. So for that, I have a separate example. Let me pull that up here. Okay, so in the new versions, I think around Solid Edge version 2022, a new command was introduced or a new way of interacting with the intersecting frame members has been introduced. So here, as you can see, this cross member is intersecting with this base. So uh, very easily we can trim off the regions. For that, all you would have to do is find that frame member. So this frame member here is frame 6. So I'll go here, say edit this frame under end conditions. Which two end conditions I'm focused on is going to be this one right here and this one right here. So these two end conditions. And once you do that, sorry. So these two frame end conditions, and how would you like to extend or trim them? So this is a command that has been introduced. That's called as extend/trim. So here, once you select that, up to which faces do you want to trim them off? So I'll say instead of all, I'll say select faces, and the faces I want to use is face 1, 2, and 3. So once I have these three faces, I'll say okay, hit the screen check box, and the software trims off very nicely that intersecting frame member. So very clean and easy way of doing that. Now you don't necessarily have to always go inside and find the frame member which is intersecting. You have that command right under this frame group called as trim and extend. Now as the command says, you can also trim and also extend using that single command. So here we saw how you can trim it. Now we'll see how you can extend the frame members. Again, here the way you can extend that is you first select the target step. So this is going to be my target face of the frame, and I want to extend this up to this frame, right? So I'll say select the faces up to which you want to extend. So if I select this face, it is going to only extend up to that face. But if I select these rounds, it is also going to wrap around those rounds, which is quite interesting. So if I hit accept, you see how it wraps around those rounds as well. So same thing on the outside, on this side, and also this side. Next thing we have is, what if you want to create a certain gap which can be used, let's say, for welding, right? So if I go back to this trim and extend, I'll select this face right here, and now I'll just select one face. But now instead of moving it up to that face, I want to add a weld gap. So I'll say add a weld gap. Let's do the default 5 mm weld gap. And if you take a look from the front view, this is what that 5 mm weld gap looks like. Next, what if you have more than one face? What if you have two different frame members up to which you want to move it to? For that, you can go to trim or extend again, select the target face tab, and then you can select the two parts up to which you want to move. So instead of face, I'll change this to body. I'll say turn on the body. And now since we don't want a weld gap, we'll say copy it up to those faces. And if you hit accept, the software generates a frame member extending to two different cross frame members in this situation. So these are the new updates that have been introduced in the newer versions of Solid Edge. So speaking of trim and extend, here one thing I noticed is that if you see or take a look at closely here, you see how this frame member is intersecting with the bottom face. So this is what I was talking about that might happen sometimes. Extend that frame. So we'll do something similar to what we did on the previous example. So I'll go to my frame environment here and try to trim off that face. So you select that face, right, and the body up to which you want to trim off. So it trims off very nicely over there, and same thing we'll do on this side of the frame as well. Now, now we know that we can very easily create the frame structure for any assembly. But how about the strength of this frame? How do we know this frame is strong enough to hold the entire structure in place? So for that, what we have inside frames is the capability to simulate the frame for different types of analysis. So if you come to this drop down, you see we have a whole lot of analysis that you can do with frames. You have your linear statics, you have your modal analysis. If you're trying to check for buckling on the structure, in this situation we don't have like slender members on which a load is applied. So we will most likely stick to linear statics. But apart from that, we have linear buckling, we have heat transfer, we have harmonic responses, and then we have the steady state and transient heat transfer. So these are the different types of analysis which Solid Edge can do. Now we'll stick to linear static, and for the mesh type, if you see, it defaults only to beams. So it is creating RB2 elements, RB2 and RB3 elements for each of these frame members. And a really good thing about this is, since it's RB2 and RB3, it's a 1D element, the solution time will be way faster. Now, what we do is here we'll decide what is going to be the maximum rigid link length. Now, this is very important here because in certain regions, like where the two frame members are touching each other but not necessarily a part of the same frame section, will have to be linked to each other with this rigid link. Now, the higher tolerance we set, let's say for example, if we set this to 200 mm, the better it can capture the closer frame frame or the beam members. And then we'll see what kind of results do you want to see. The I would like to see the end reactions, I would like to see the applied loads, and hit OK. Now here I'm just going to select the frame members, so I'll select all the frame members that I'm interested in. So it's frame 1, uh, 2, 3, 4, and 5. So these are all the frame members which I want to include in my analysis. And so here we have defined the RB2 or the links or the rigid links here. So if you see, this is what I was talking about. Sometimes what happens is when you have two frame members touching each other but not necessarily a part of the same frame, this we have to generate a rigid link, which is this dark blue line, which makes sure that this beam is connected to this frame right here. That way you don't have to generate, let's say, your constraints or sorry, not constraints, the connectors, like the automatic connectors, the manual connectors, what kind of interaction will be taking place between the two frames. So the rigid link length solves that problem very easily. Now, next step, what we'll be doing here is we'll be defining the boundary conditions. So the bottom of this frame is going to be fixed. So I'll select all these curves here very easily, and I'm going to fix the base of this frame. So we have applied a fixed constraint to the base, which means that all 6 degrees of freedoms for this base of the frame are locked. And now we'll be defining the faces on which the load is applied. So since the load is distributed evenly, or in this example, we'll consider it as distributed evenly on the entire top of the face, I'm just going to say go to force and specify the faces. So I'll so 1, 2, 3, this fourth member over here, and also the cross members. Now, since some of this load is also distributed on the these two raised members, which is going to be the load of the tank. Now, since I don't know the exact load or the load distribution of the tanks with respect to the entire assembly, I just know the overall load is 50,000 Newton. So I'll just type in 50,000 Newton. So that load has been applied, and we can flip the direction using this arrow right here. So we have our fixed constraint and the load applied. Now, once we have all of these things, we can go ahead and solve the model. But before solve, we'll have to mesh the model. Now you can use this slider to reduce the mesh size. So I'm going to use a mesh size of 8.75 and just hit this mesh and solve option. So now the software will start meshing my model and solving the model, and giving out the results in the post-processing window. Now once you'll see that, so now once this post-processing status has been completed, you'll see that the results are generated on the frame, and you'll see all the deformations and the stresses and at what locations are those stresses being induced. So so this is the result of my frame deformation. Now you don't have to be way too worried about the structure it looks like, because right now the deformation is not an actual deformation but a 10% exaggerated view. So if I take a look at the actual deformation, this is what my actual deformation will look like. Now, the most important thing that we have to be focused on here is the stress, right? So the beam max combined stress here is, so the max stress here is 223 megapascal, which is still less than the yield stress, which is 262. So we are still within this 262 limit. But if we were to cross this 262 limit, we need to find out which specific regions are going to be where the stress is induced the most. So for that, I'll change this back to my percentage view, and instead of 10, I'll do, let's say, a 5%, and I'll try to animate. Now, if I animate, you see this is how my deformation is going to look like, and the high stress regions is going to be this region right here. Now, if I stop at this region, hold on. So if I stop at this region right here, you'll see if you try to match the contour here, it's 223 red, yellow. So this is where my highest stresses have been reduced. So this is going to be one corner. The other corner is going to be right here, on the back face right here, and all the four sides. To very quickly see where these max stresses have been induced, we can display them with the markers. So let me put this back into actual view, and I'll go to the display, or sorry, color bar, and turn on my minimum marker and the maximum marker. So if you see, like I said here, the max marker here has been noted at this location. This is where the maximum load has been applied, and the minimum load, or the minimum stresses, sorry, have been induced at this point. So with use so by using this solid edge simulation and frames, you can very easily analyze a frame, and then you can add some stiffening members. Like for example, here, if you think that when you try to animate, you see how this deformation is happening. So if you don't want this deformation, okay, so let me go back here and do a percentage, and then animate. So now, if you don't want your frame members to be dipping down like this, what you can do is you can add some additional frame members in this region, so that there is some extra support. Now, one more thing that I would be focused on is going to be the displacements. So what's the total displacement here? So the highest displacement, as it was very clear from the animation here, is going to be at the center of this region, like this. The max displacement here is 13.8 mm is going to be the max displacement. So we definitely need to add some stiffening frames here, which will provide this frame and this entire frame assembly some extra strength. Now, just to save us some time, what I've done is I have pulled up one example which I made, and I've added these stiffening members here, like I discussed. I've added like 80 by 80 by 5 frame cross section, sorry, 80 by 80 frame cross section on 3 on this side, same on the back side here. I've added 3 more, and 2 on each side here. And I've also used the same results, or sorry, the same loads and boundary conditions I used for the previous example here. That is fixed on all four sides, and load applied, that is 50,000 Newton on the top faces of the frame. Now, if you take a look at the results, there have been drastic improvements in the result. So if I go to viewing the results here, again, this is going to be an exaggerated view, so don't be way too worried about that. But if you see now, the max stresses have been reduced from 232 to only 39.1 megapascal, which is a great improvement. And the location of the high stress concentration regions has also been shifted from our corners to the center members here. So if you go to your color bar and turn on your min and max markers, you see My minimum location is going to be this spot right here, and the max location here, like I said, is now at the center. So very easily, by adding stiffening members, you can find out the locations where high stress concentration regions are. And also let's take a look at the displacement results. So the displacement results are going to be right here. I'll just do a total displacement. And for total displacement, again, you see we have reduced from 13 mm to only 2.6 mm, which is a great improvement. So if I go back to my home, and in a percentage view, it looks like it's deformed, but the displacement is not way too much. I'll just change this to 5. And if I do an animated view, you see this is how my new frame structure will behave based on the new arrangement and the new stiffening members, and which makes sense. And also, like I mentioned, we have reduced the displacements from 13 to only 2.61. Now, a really good thing about creating these simulations within Solid Edge is if we can generate a report right from here. So if you generate a report, uh, you can give it a name, let's say frame simulation report. The author, the company name, if you want to add something, some introductions and conclusions, you can add here, and what format you want this report to be generated in. So it will take some time and generate a report. So here we have generated this report, which looks something like this. So frame simulation, we have a table of content. So at first it'll start with what kind of study we have performed, what kind of mesh type we have used, and what all parts have been included in this analysis. So for this specific example, we have only used frames. So all the members here are going to be the frame members. Then what are the material properties we have used for the frame, or those frames? So we have used a steel frame, what density, what is going to be the modulus of elasticity, Poisson's ratio, what are the loads that have been applied, the constraints, and then the results. And you get these results in the form of the total value and also individual axes. So we have displacement result, we have a beam combined stress result, equilibrium result, and then the place where we had an option to add the conclusion, you could have added the conclusion right here. So what do you think as an analyst you would add as a conclusion here from the report, and then you can submit this report for workflow. So this is all I had to show you guys today